morning everyone and welcome back. I hope you would have enjoyed your weekend. So in our previous lecture we discussed research and data collection techniques. Different data collection techniques in quantitative and qualitative research. So today we are going to start a new chapter, and this is chapter number 12, and it is about selecting a sample. So if you have any questions about your previous chapter, you can ask. Because we discussed the different data collection methods used in quantitative research and also in qualitative research. We discussed observation, primary and secondary sources, or the primary data and secondary data. In primary, we discussed observation, interviews, questionnaire. And we also discussed the different advantages and disadvantages, the different characteristics of these data collection techniques. So one method can be used to collect data both for qualitative and quantitative research. For example, I give an example of observation. It totally depends on the respondent how you record the responses, the information that you collect from your respondents. In observation, you can the information you collect it, you can record it in a descriptive form, narrative form, in short notes, description. That is used for qualitative research. But the same type of data, the responses that you can record in category or in a scale, so that is used for quantitative research. So same in interviews, same. So we can use the same kind of data collection method, same type of data collection method for different research, whether it is qualitative or quantitative. This chapter is about selecting a sample. Okay, after when you have decided about the data collection method, after when you have decided about the instrument, the tool that we use in order to collect data for our research, then we need to decide about, we need to select a sample. Because one is study population. If you want to study the whole China, it is not possible. It is very difficult to collect information data from each and every respondent in China. Or for example, some international organizations, if they want to do research in the whole world. So it is very difficult to collect information or data from the people all over the world. So what do? We just choose a sample of the overall study population. For example, this WKU students. If you want to see the average age of the students at WKU, what do? You don't need to calculate and ask all the students at WKU about their ages. We can just take a sample of 200 or 300 students. We can ask them about their ages, and then we can calculate, and then we can make some inferences, some judgments, some estimates, some predictions, and then we can decide about the average age of the overall WKU students. This is for sample. So how to choose the sample, the study population, and then sample, what strategy you should use, the way you collect, you select the sample, the sampling unit, sampling element, your respondents. Because most of your research, it is either about your customers, maybe employees or managers. So you need to decide about who is your respondent. We have already discussed this. who is responding, you already know. Now, you need to decide about, because some students ask me about this question, Professor, how much data we should collect, how many responses, how many questionnaires, some of you are using questionnaires, so how many questionnaires should we collect? So this we'll discuss in today's lecture. There are some chapters. These are the topics that will be covered in our today's lecture and in this session. First, we will discuss the differences in sampling in both quantitative and qualitative research in these two approaches. Then we will discuss the definition of sampling terminology in quantitative research, because most of us we do these quantitative types of research. So we will discuss and we will see, we will define what is sampling, or the definition of sampling in quantitative research. Then there are three principles of sampling. So we will also study these three principles. These are important. If you want to do quantitative research, we need to understand these three principles. Then there are different types of sampling. We will discuss each and every type of sampling in detail. The first one, and this is most widely used, random or probability sampling design. This sampling design or sampling technique strategies used widely in quantitative research, and also most of us in social sciences, in management science, we use this kind of sampling design or sampling strategy. The second one is non-random or non-probability sampling designs. This kind of sampling or type of sampling is used in qualitative research. Also, these are used. We will discuss which type of sampling design we should use and why we should use this. It has advantages and disadvantages. And the third type of sampling is the mixed sampling design. We will discuss this. Then the sample size. In different studies, in qualitative, quantitative, the sample size is different. And the sample size is decided by different factors. It also is influenced by the characteristics of the study population. For example, if you want to see the average age of the students in this class, so most of you, somehow, you have more or less similar, same age. There will be very less difference. But if you want to see the average age of the student, where one student is 20 years old, another student is 30 years old, another student is 45 years old, so then the sample size will be different as compared to the students. Most of the students, they have almost same age. 20, 21, 22, 21.5, 21.7. So these are considered as homogeneous, means more similar. But if there is one student who is 20 or 21, another student who is 35, so the gap is very big. So here there is diversity, or we call it heterogeneity. Anyway, so these are the factors, are the type of accuracy that you want. The confidence level, we will discuss this later on. This will influence your decision about sample size. The last one is the concept of saturation point in qualitative research. In qualitative research, when we collect data, a point comes where you stop collecting information. That point where the information collected is meaningless, or where the information that you have collected is negligible. That is called saturation point. We'll discuss this. What is saturation point? Differences in sampling in quantitative and qualitative research. Alright. So here, when we conduct quantitative research, we try to select the sample size, we try to collect the respondents, and this technique, the strategy, the design we use is unbiased. Unbiased means where you have little or almost no human choice. Your personal choice, your personal likes and dislikes. Understand? If you want to collect data from this class where half of the students, their age is 20 to 25, and half of the students, their age is 40 to 50. If you only collect data from 20 to 25 and then you say, okay, the average age of this class is 23. Is it true? Half of the class, the average age is from 20 to 25. Another half is 40 to 40, about 30, right? You only collect data from 20 to 25. You forget about 30 and above. This is not true representative. Here it is human choice. It is biased. You only focused on data from data collection from 20 to 25 students, right? So your result will be, what will be your findings? That the average age of this class is, let's suppose 23 or 24, but you also have people who are 34, who are 40, who are about 30, and half of the class is about 30. So you cannot say the average age is. It is because you collected data only from 20 to 25 years old students. It is biased. So in quantitative research, what we do? We try to be unbiased. We do not bring our personal likes, dislikes, personal choice into sample selection. We try to give each and every respondent equal and independent chance of getting selected. So a 20 years old student will have the chance to participate in the research. A 45 years old student will have the chance to participate in the study. They will have equal and independent chances. So then you can get accurate findings, accurate information. Then representative. If you focus on only particular group of people from whom you collect the data, information, this is not representative. Okay? You should give each and every respondent equal and independent chances of getting selected for the data collection. If all of you have the equal chances of participation in the research and data collection, then representative. It means representative. And you should also, for example, if there are 30 students, if I only collect data from 5 students, is it representative? Can I say, okay, 5 students, their age is from 21 to 22. So the average age of this class is 21 or 22. It is only possible if it is, the difference in the characteristics of the respondent is less. Every student is 21 or 22. Then in that case it is okay. But if you have large samples, have a study population, and it is heterogeneous, they are not the same, and if you only select, for example, out of 100, you only choose 60. It means 40 is not included, right? Or you only focus on 50, 50 is not. So in that case, this is also, I know, you need to give the justification why you choose this sample size. But the sample size that you have selected should be representative of the overall study population. Why it is important? It is important because you make judgment, you make decision, inferences, you make some prediction based on the sample about the overall population. You understand? What is your second assignment about? It is about writing introduction, research objectives, and research questions, right? So your research question is about not about sample, it is about overall study population. Okay? You want to see the customers, their intention, their behavior, or the managers, their decision making, their investment decision making, or strategic alliances, or big data analytics, or AI capabilities. So you want to see about the overall study population. You have some research questions, research objectives. It is about the overall study population. Now you choose a sample because it is very difficult, it is time consuming, you need a lot of resources, you need a lot of financial, human resources to collect data from all these respondents. What do? You select a sample and try to select a sample that is unbiased, representative, and then you make inferences. Inferences means you make some predictions. Okay, we collected data from 350 respondents. Based on this data, then you use some statistical tests. You will get some results. You will get some findings. And then you can make some decision. The findings will show you, results will show you some. You make some inferences, some estimates, some predictions about the overall population. Understand? That's why it is important that your sample size should be representative of the overall study population. If it is not representative, the inferences you make, the judgments, the decisions, the estimates, or the predictions that you make, it will be biased, it will not be true. You will not get accurate information. Random samples, here we do not focus on particular group of people to collect information. What we do, randomly we select sample. It means we randomly ask respondents to participate in the study. So here, random means that each and every participant will have an equal and independent chance of getting selected for the study or for the data collection. Large sample sizes, when we use qualitative study, when we do this quantitative research, the sample size is comparatively large as compared to qualitative study. Here in qualitative research, what is the difference? Here we focus on it should be unbiased, ease of access, purpose driven. Ease of access means we select people. It is judgmental. We use our own judgments. We select people we think they can provide us all the information or best information. There is no random sampling. So if I know that these three people, they can provide me the best information, I will only collect the data from these three people. This is not random. Okay? So there is a chance of biasness. But because I believe these are the people who can provide me the best information, the best data, so I will only focus on this. And because only my purpose, I want to achieve the purpose. I want to investigate a particular value, a particular attitude, particular behavior, particular intention that certain people they have. I just want to know. Okay? Then information rich respondent, because these people that I collect for data collection, they have all the information, they know about a particular problem, so I can get best information from these respondents. A few cases as compared to quantitative research, as sample size is large, but in qualitative research we only focus on few cases. We only collect data from few respondents. Here it is a simple, you can say about, this is a sketch. Picture, it shows the concept of sampling. How? Here there is a study population, and it is also called sampling units. Here this is sample. Out of, because if your study population is very big, for example, if you want to know the average family income in Bangalore, so you cannot collect data or information from each and every family living in Bangalore. What you will do? You will select few sampling units. Instead of all focusing or collecting data from all the units, sampling units, you will only select few sampling units from the study population. This is called sample. What do? You collect information from these people to find answers to your research questions. Just now I mentioned. You have research questions in your introduction, and these research questions is related to your overall population. It's not about a sample, okay? Try to understand this thing. The research questions are objective is about the overall population. It's not about sample. So, you collect the information, then you process the information, you analyze the information, you will get some results, and then you will make some inferences, some judgments, some predictions. And then, from this one, from sample findings, you make an estimate of their prevalence in the study population. Then you apply this generalizability. If your sample is truly representative of your study population, the information, the data that you have collected from the sample, then you process the information, you get some results, findings, information. Again, you make some estimation about the overall population. In the sample, this is the thing that is happening. So we assume, we estimate, we predict it will also happen in the total population. Okay? You can study the average age, height, whatever of the students in WKU. You also can do research about the average income of the families in Bangalore. For example, the best example is election. In different countries, in different organizations, they do have elections. So not all the people, 100%, they take part in election. So if there are, for example, 60% turnout or 70%, it means 70% of the people, they have shown their interest in election. I mean, they have chosen their representatives. So based on the results from these 70 people, they actually decide about the government. This is the concept of sampling. And here is the definition of sampling in quantitative research. Sampling is the process of selecting a few. Selecting a few means sample. Sampling units, elements, respondents, participants. Selecting a few from a bigger group. Study population. If you want to study the overall country, region, city, so this is called study population. And if you select few, sample size, that is called sample size. For what? The sampling population. To become the basis for predicting an outcome for the bigger group. So your main focus is on the bigger group, study population, not sample. Based on the sample, actually you select a sample, you analyze, you collect the data, you analyze, you get some results, findings, and then you generalize to the overall population. So there are advantages and disadvantages. The main advantage is doing research about the sample is easier. it is easier to collect data from few respondents instead of overall study population. It is less costly. You don't need to spend a lot of time. You don't need to spend a lot of financial and human resources in order to collect data from a sample or to do research about a sample. Disadvantages might be, this is also we will discuss in the coming slides. There is an error. The sample and the sampling population differ. The sample and the sampling population. The sample may not be truly representative of the overall study population. So you will have problem. Even if you will have some results, but the results are not accurate. The results are not true. This is not true information, true predictions. Understand? Any question? Any question, please? There are some terminologies that we need to understand. Study population, I think now you all know, right? If you want to study WQU, the students of WQU, so WQU is study population. Or if you want to know the average family income of the people, families living in Venjo. So the whole Venjo are the families in Venjo, living in Venjo. This is the study population, right? Our customer, if you want to see the attitude, perceptions, behavior, intentions, investor decision making behavior, or intention about specific group of people. So this group of people is called study population. Then sample size and the number of items or people in the sample. You select few from the larger, the bigger group. So these few respondents, these few group of people from whom you collect the data, this is called sample size. Sampling design or sampling strategy, the way you collect or you select the sample, how you select or the way you select the students, for example, the families or electors, this is called sampling design. It can be random, it can be non-random. You can focus on, okay, I will only select these students to collect data from. I do not collect data from you. This is called sampling design. It is non-random. If I only focus on the right part of the class. If I ignore the left part of the class, none. But if I randomly ask students, I do not know, okay, this student will provide information random. Alright, sampling unit or sampling element. Each student, for example, if I want to collect data from you for my research about, I want to do research about your average age, you are what? The student is sampling element or sampling unit. Or the family, if I want to know about the average income of the family. So the family is sampling unit, sampling element or participant in my research. Right? Then sample statistics. These two are important, you need to understand. Sample statistics are the results found in the sample. You select the sample and then you get some results about that sample. This is called sample statistics. And then population parameter are the estimates for the population from the sample statistics. It is about the population, about the study population. For example, the average, the mean of the sample, the mean of population. So we will discuss how it can be different, how it can affect the findings. Principles. You need to keep this in mind and you need to understand. Principle number 1. There will be difference between the sample statistics and the true population mean. two mean, two averages. One is sample statistics. Sample statistics means over a WKU, this is study population. The average age of the over a WKU students is called population parameter. But if you select 200 students, their average age is sample statistics. So the average of the sample statistics and the average of the population, study population, it will be different. This is principle number 1. This is the standard. Here you can see there will be a difference between the sample statistics and the true population mean, which is because of the selection of the errors in the sample, or which is attributable. Here you can see. Let's suppose, for example, if we select 4 people, A, B, C, and D. If you want to do research about the average ages of these four people. And for example, if A is 18 years old, B is 20, C is 23, D is 25. So now you want to know about the average age of these 4 people. So what is the study population? How many people in the study population in this case? Do you know how many students in the study population? 4. Okay, A, B, C, and D. This is study population. Now, if you want to select sample size 2 of 2, right? How many options do you have? 6. A and B, A and C, A and D, B, C, B, D, and C and D, right? So now you have how many options? 6. You can calculate the average age of these sample of 2. This you can add, divided by 2, and you will get the average age. It starts from 19 to 24. Here you will see the difference between, this is sample statistics, right? Sample statistics of the sample of 2, right? How many students? How many people in this sample? 2. How many people in the sample? 2. Study population? 4. So I selected 2 from 4. This is the sample average or sample statistics. This one. What is the population mean? You can add this A, B, C, D divided by 4. The average of the population is 21.5. Okay? How much is the difference? From 2.5 minus 2.5 to plus 2.5. It means only in 2 cases, the sample statistics, this is population, study population statistics, their average, and sample statistics, their average is the same. But in other cases, it is different. Minus 2.5 and plus 2.5. Right? The average of the sample, the average of the study population is different. Principle number 1. Principle number 2. If you increase the sample size, in the previous slide, what was the sample size? 2. Now, if you want to increase the sample size from 2 to 3, what will happen? The difference between the sample statistics and population parameter, I mean, the difference in the mean of the sample and the study population will decrease. How? We can see. Here, if you want to see, if you want to select sample of 3 people, so how many options do we have now? Theory of probability, we can have 1, 2, 3, 4 options. How many? 4. Alright, you can calculate their average ages of each sample. Each sample. Here you can see it ranges from 21 to 23 to 22.67. Now we can see how much is the difference. This is the average age of the sample. This is the average age of the population. This is the difference. If you increase from 2 to 3, how much is the difference? 1.17. From minus 1.17 to plus 1.17. How much was the difference in the previous slide? Population of 2, sample of 2, sorry. How much was the difference? This difference? 2.5. Now it is 1.17. Because we increase the sample size from 2 to 3. The difference in the mean decrease. You understand? What does it mean? It means if you want to get true information, true findings, if you want to get true estimates, predictions, accurate predictions, try to increase the sample size. This is called error. Sample error. The difference in the sample average and the population parameter. So if this difference is big, what will happen? The results, the finding that you get will not be the true representative, will not be accurate. So try to increase the sample size. If your sample size is small, that's why we always say, always students they ask me, Professor, how much data, how many responses should we collect for our study? I do not have an exact number, but the only answer, the best answer I can give is the more the better. So if your sample size is bigger, the results that you get will be better. They will be truly representative. Because if you increase your sample size, many people they will be included in your study. So you will have different backgrounds, different opinions. This will be the true information actually you are looking for. True data. Any question? Understand? Okay. Principle number 3. Third principle. The greater the differences in variables are the characteristics of the variables. The greater the differences between the sample statistics and the true population mean. Sample, the study population means. What does it mean? What does it mean? It means, for example, in this class, if I want to see the average age of the students, if there are some students whose ages are 20, 21, 22, but there are some students whose ages are 30, 35, 40, there is greater differences in the variable. Do you see? Suppose last time we selected 4 people, A, B, C and D. Their ages were 18, 20, 22, 25. Now let's suppose their ages are 18, 26, 32 and 40. There is significant, there is difference in the variables. Differences in the variables are big. So now you can calculate the average. The average age in the case of, let's suppose, if you select a sample of 2, select a sample of 2, how many options do we have? 6. Right? Select a sample of 2 out of 4. So we have 6 options and the average, the difference ranges from -7 to +7. But if you increase the sample size into 3, what is the difference in the average or the mean of the sample statistics and the population? It is plus 3 to minus 3. So you can compare in first case, in the previous slide, when the average age or the ages of the 4 people, they were 18, 20, 22, 25. From 18 to 25, it is from 18 to 40. So there is greater variability, diversity in the population, right? So here in this case, what happened? The average of the sample size of the sample statistics and the average of the population parameter. So you can see in both the cases, the range of the differences is greater than previously calculated. Why? It is because of the variables. In the variables there is greater differences. Greater difference in the variables. So what are the factors that actually will affect your judgments, your findings, or the estimates, the predictions that you can draw from a sample? There are two factors that actually will influence the accuracy of the judgments, of the predictions, of the estimates, or the degree of certainty about the inferences that you can draw from a sample. What are these two factors? Just now we discussed. The first one is the size of the sample. It is related to principle number 2. So if the size of the sample is smaller, the difference in the mean of the sample statistics, the difference in the mean of the study population will be greater. So in order to reduce this difference, try to increase the number of the sample size. Understand? We just saw sample of 2, the difference was 2.5. Sample of 3, the difference was 1.17. So the difference, the error decreased. So if you increase the sample size, this difference will be reduced. So what you can do, if you increase the sample size, findings based upon larger samples have more certainty than those based on smaller ones. So they will give you accurate information, accurate findings if you use larger sample as compared to if you use smaller sample size. Findings, predictions, judgments, or results that you get will be accurate and certain or certainty. And this is the second factor. It is related to your principle number 3. Principle number 3 is what? The extent of variation in the sampling population, study population or sampling population. The greater the variation in the study population, all the variables, the respondents, so the respondents in your study population, if there is greater variation, variability, with respect to the characteristics under study, it means why we use when we collect data through questionnaire, we use different age groups, right? From 20 to 25, from 25 to 30, from 30 to 35, from 40 to 45. Same, different education. We mentioned about what is your education level. And then we mentioned about different educations. Then we also mentioned about different level of experience. I mean, how many years of experience you have. From 1 to 2, from 2 to 5, from 5 to 10, from 10 to 15. A person who is giving you information having 1 year of experience, a person who is having 15 years of experience is the same. So it means there is greater variability. When there is greater variability, what will happen? What will happen? The findings that you get or the inferences that you draw from the sample will not be accurate. So what in that case, what you can do is try to increase the sample size. Try to give chance to each and every. So in that case, in the coming slides we will discuss even in the same population. For example, let's suppose if you want to collect data from a group of people, same population, there are so many people, same population, but in let's suppose age of 20 to 25, there are millions of people. Then 25 to 30, then so you need to categorize, you need to make clusters, you need to make strata. Maybe there are people who are in one part of the world and another part of the world. You need to make clusters to collect data from all these. Okay, so the greater the variation in the study population with respect to the characteristics under study for a given sample size, the greater the uncertainty. The uncertainty will be greater. If there is greater variation, differences, diversity in the study population. Right? Alright. Just give a simple example. If all of you have same age, if I want to do research about the average age of all the students in this class, if all of you have the same age, even I can choose one student and I can say that all the students they have this age, right? For example, all the students they are 21. Because all of you have the same age, even if I calculate the average, it will be the same, right? The mean or the average will be the same. How about if there are different students, they have different ages? What will happen? So, in that case, but if it is, the difference is less. I mean, some students, they are 21, they are 21.5, they are 21.7, 21.9, some students, they are 22, 22.5. So from these kind of students, you can select small sample size and it will give you accurate information. It is okay. But if you have population, study population, where the age of the student, some students they are 20, some students they are 25, some students they are 27, some students they are 30, what you need to do? If you select a small sample size and you get some information, you cannot make accurate or correct or certain inferences. So in that case, what you can do is you try to increase the sample size. You see here. But if it is heterogeneous, it means that the people, the respondents in your study population is dissimilar or diversified, you need to select a larger sample to obtain the same level of accuracy. Understand? Okay. Here, how you can get better results? Simple words. If this is the study population, I want to know about the average age of the students in this class. Number one, if they are homogeneous, means same age, I can choose just one student and I can say all the students they have this age. The information is accurate. Okay. If their ages are different, some students they are 21, 25, 27, 30. In that case, I cannot make better judgment based on a small sample size, right? What I need to do is, you need to select a larger sample. So more people, they will participate, different ages, some people from 35, some people from 21, from 27. So all of them you can collect the data about these students and then you can calculate the average. There will be some error, but it will be accuracy will be high. Right? You cannot get exactly 100% accurate result. It might be some more positive or some negative. Okay? Okay. Why we select a sample? Definitely, number one, it is difficult. It is somehow impossible to collect data from the overall study population. So what we do, we select a sample, we collect data from the sample, from those group of people. Our main purpose, our aim is to achieve maximum precision in estimates within a given sample size and to avoid biasness. Two main objectives. To achieve maximum precision means accurate judgments, predictions, estimates, inferences, findings about the sample and we can generalize to the overall study population. Second, try to avoid your biasness. Biasness means your personal choice, personal likes, personal dislikes. If you decrease this personal likes and dislikes, personal bias, your results can be better. So how we can do this? Bias in the selection of a sample can occur if sampling is done by non-random method. Non-random method means you select a sample, respondents, where each and every respondent, each and every participant will have equal and independent chance of being selected for the data collection. Well, each and every student knows, okay, I have the equal chance, and if I will select this student, it will not affect the selection of another student. It is equal, independent, and independent of, selection of another student. So that is if the selection is consciously or unconsciously influenced by human choice. Human choice. Your likes and dislikes. If your selection is based on bias, your personal choice, I only consider few people to take part in the data collection. This is not truly representative of the overall study population. So I cannot get better results, right? This is one thing. Another one is the sampling frame. The list, the index, the list of or other population records, the people, the respondents, which serves as the basis of selection. List of people, okay, the study population. This is the study population list of people who will participate or in the study, in the data collection process, in the information gathering process. The index, the list, whatever, does not cover the sampling population accurately and completely. If you want to collect data from students, but in your study population, there are only few. That's why when I ask you, it's okay if you want to ask your friends to help you fill the questionnaires. But the thing is, this list, if you want to collect data from CEOs or the managers, or you ask your friend, okay, please help me fill the questionnaire as a CEO. Does it cover the list, the number of respondents? How many CEOs do you have in your list? I know you are future CEOs, but now you are not, right? So you cannot give. So this is the thing, this is the problem. And if you are not the actual CEO, but you fill the questionnaire as a CEO, what will happen? You will not give the true information, right? Information you provided is not accurate. The last one is some people, some respondents, they do not want to participate in that, they do not want to cooperate, or they are not accessible. They refuse to cooperate or they are impossible to find or they are not accessible. So if you cannot access your study population, the sample, the people who will actually provide you the information, what will happen? It means you will miss those people. They will not take part in the data collection or the information gathering process. But might be their information, their data is extremely important for your study, your research. So this is also, you cannot get accurate or correct judgments or inferences. Any question, please? Do you understand this? Okay. Now we will move on to types of sampling. There are broadly we can classify sampling into three types: random, non-random, mix. It's also called probability, non-probability, and mixed sampling or systematic sampling. In random sampling, and this is widely used. In most of our quantitative research, we use random or probability sampling design. Here we use in random, there are three again: simple random, stratified, cluster sampling. In simple random, I think we can explain it from here, is okay. Simple random sampling, this is called SRS. Okay, so just explain it a little bit, then we go to the next slide. Simple random sampling is SRS, widely used in quantitative research. Then we have stratified. In stratified, we have two: proportionate and disproportionate stratified sampling. Then we have cluster. In cluster, we have single stage, double stage, and multi-stage, different stages. If you want to collect data in different stages of a process, of an event, of a situation. Non-random, this is in qualitative research widely used non-random or non-probability sampling. Quota, judgmental, convenience, accidental, this is also called convenience or accidental, snowball or expert sampling. And the last one is systematic. So we'll discuss each one by one, a little bit in details. Random or probability sampling design. Here each element, each respondent, each participant in this sampling frame has an equal and independent chances of selection in the sample. This is called random sampling. And this is the most appropriate, the most representative of your study population. Because here every element, every respondent, every participant has an equal chance, and this equal chance is not affected by the selection of another respondent. This is what is the advantage? Number one, the biggest advantage is it is representative of total sampling population. So if each and every participant knows I have equal and independent chances of being selected, and if you select your sample based on non-random probability sampling design, they are the truly representative of overall study population. If you only focus on, if you want to collect data from CEOs and you actually collect data from CEOs, not from students of WTU, okay? Then it is called, they are truly representative of actually the accuracy of your findings, of your estimates, of your predictions will also increase. You will make better results. But if the students they feel 1 7 7 7 7 7 5 5 5 5 5 because they just want to help you because being a friend. They just want to fill the questionnaire, but this is not the true information you are looking for. So you will face problem in your analysis, your results. Reliability, validity, which we'll discuss in the next chapter. And I will teach you some methods. How to use SPSS and AMOS or some other software in order to analyze the data. Okay, so when the problem is, when you select a sample, and that sample is not truly representative of the overall study population, you cannot make judgment, you cannot make decision. That can be generalized. For example, if you conduct a study here in Vanjo, only in Vanjo, for example, about the customer preferences, you collect data from people, from customers in Vanjo, then you get some results. Can you generalize these results to all over the world? Because in different part of the world, the customers, they might have different traditions, different cultures, different customs, different attitude, different education level, different. How many differences, right? Everything is different. So you cannot. But what you need to do? Try to increase the sample size. Randomly choose, select population. The samples. Respondents. Some statistical. Okay. Another thing is when you collect data through random sampling or probability sampling design, there are some statistical tests which can only be applied to this data collected through random sampling or probability sampling. So this is another advantage. It means that these statistical tests cannot be applied to the data collected through non-random or non-probability design, sampling design. Alright, so some specific random sampling design. Random sampling design. First and the most important is we select the respondents, we select the sample randomly. All the respondents, all the people who will take part in the data collection process, they will be selected randomly. Number one. Second, each and every participant will have equal and independent chances of selection. So in this we can broadly categorize into three, we can classify into three. Number one, SRS, simple random sampling. This is most widely used in quantitative research, where we select people, especially when we use questionnaire to collect data from diverse group of people. So simply we randomly send. Nowadays we have online platforms. You can post your questionnaire, and this questionnaire is being sent to different people, different regions, different educations. It is important. Why? Because now you are targeting each and every individual. It is comprehensive. For example, you will have the opinion of the person who is 20 years old, but that person is an employee. You will also have the opinion of the person who is 55 years old. So diverse, different education, different number of years of experience, different income level, different status, for example, married, unmarried. So that's how we can collect the data. Stratified random. So you can make stratum, we call it stratum, different strata, different groups. So you can make this strata or cluster. And this, okay, first we discuss stratified. It can be proportionate or disproportionate. Proportionate means, for example, you stratified people into based on some characteristics. Age, for example. Okay, age groups. We have age groups. 20 to 25 age groups. So then we decide. We collect data from all these strata. One age group, another different strata. Okay? Clusters. So it can be proportionate or disproportionate. Maybe for example you can decide equal how many proportions are percentage of this age group, this strata, this. It totally depends on you and the purpose of your study. Cluster. For example, if your respondents are geographically dispersed in different parts of the world, or maybe you can take example of China. China is very big, okay? So we can have managers, customers, or employees who are geographically dispersed. So you can make cluster. This is eastern part, western part, northern part, southern part, central part, and then you can make clusters and you can collect data. Okay? Then you can analyze. Any question, please? Huh? All right. Next is non-random, and which is used in qualitative study mostly. In qualitative study they use non-random or non-probability sampling design. The first and the most important is quota. In quota sampling, if you need a specific number of respondents or some specific information, if you say, okay, I need to collect information from 20 respondents, 20 students. So one student, when will get in, okay, you will ask the information, another student, until when you collect it from 20 students. That's it. Your quota is finished. You have collected the data. This is called quota sampling. Understand? Second, accidental or convenience sampling. So it is up to your convenience, and you choose people who you think can provide you. Also, it is related to the judgmental. Who you think can provide you the best information. So you make your decision, judgment based on your experience. Okay, these are the people. I need to focus only on this. I need to contact these people, and they will provide me the best information, which you think will solve your purpose. Expert sampling here, although you can select these experts, but they are experts and they know about the specific field, the specific topic. So they will provide you those information. Expert sampling. Snowball sampling. First, I ask these 4 students, okay, for example, if I ask them, please provide me the information. They will provide me the information, then I will ask them, can you please refer some give reference, other students. They will refer some other students who will provide the information, and then those other students will refer some other students. So this is a snowball chain, okay. First 2 students, then 10 students, then 20 students, then it goes on. Snowball. Alright, the most important question. It may come to your mind. What should be my sample size? How many responses should I collect? So there are different factors, multiple factors that influence this decision about sample size. If your respondents, they have similar characteristics, same age, same education, same income, everything is the same, you can only choose few and then it's okay. They will provide you the information. Everything is the same. Everyone will give you the same information. So you don't need to waste your time, and you don't need to collect information and data from each and every respondent. What you can do is you can choose just a few, and they will provide you the information. If here you see, the greater the heterogeneity or the diversity in what to be found out about, the greater the number of respondents needed to be contacted. So if they have similar characteristics, only few respondents are enough. If they are significantly different, if their education level is different, if their income is different, if their ages are different, age is different, right? What you need to do is increase the sample size. Try to collect data from more respondents. That's how it can help you. It can help you to get better results. So you need to collect data until you reach the saturation point. Saturation point means here at this point the information collected is meaningless or it is negligible because you have already collected the information that you needed. There are some other factors that can influence your decision about sample size. Especially if you want to establish correlation, if you want to establish association or cause and effect relationship studies, we need to consider the level of confidence, confidence level, confidence interval. How confident you are that A has positive impact on B. 95%, 97%, 99%, or how much? So, confidence interval. We will discuss this when we will do some analysis. I will teach you. Degree of accuracy, how accurate should be the results, the findings, the cause and effect. Again, there are some statistics. Nowadays we use some statistical methods, some values that actually determines the degree of accuracy, the level of confidence, and the level of variation. Level of variation. You need to consider all these things when you do studies, where you want to establish, where you want to find out the correlation, the association, the cause and effect relationship between or among the variables. And the concept of saturation point in qualitative research. Qualitative research, when we conduct qualitative research, we use non-probability or non-random sampling design. We select respondents, sampling elements who we think can provide us the better information, the best information. Collecting information, okay. And then we collect information from predetermined number of people. We know who is our respondent and how many people will provide us this information. Predetermined number of people. So we collect information until the saturation point is reached. So we collect information, we continue collecting information until we get all the information we need. And guided by judgment, here we select the people who we think can provide us the best information. Best information. This is qualitative research or saturation point. Simply we can say the whole chapter is about in quantitative research. We use random sampling or probability sampling design, which is representative and we can get better results, findings. The second one is in qualitative research, we use non-random sampling techniques. Thank you very much. Any question?